All right, for those of you who just joined, right, we're copying down this table. And I'll say it one more time. This table was supposed to be an activity that you guys do after the first test. It was going to be homework, but I didn't feel comfortable with making you guys go out to drive just for this assignment. So we're just going to be using last year's numbers, okay? And everyone's just copying down this table. And then once they copy down the table, they're going into the Pear Deck. And the Pear Deck is posted. And they're using these points to graph a scatter plot here using these points up here. Understanding that the x-axis is going by increments of 1 minute, right? And the y-axis is going by increments of 2 miles, right? So each dot is representing 2 miles, okay? And we're just drawing off our scatter plots for this right here. So we're just drawing a bunch of dots. Kimberly, very nice on the numbering all the way through. Same thing with Calvin, that's good. Riley's already in there making the dots, good. Very nice, guys, very nice. You don't have to number them all, right? Just understand that it goes by twos. If you guys want to, that way it'll save you some time from trying to draw out the numbers with your mouse. But good job, there's 30 of you guys on the 31 of you guys on the Pear Deck so far out of 36. Right, some of you guys probably still copying down the numbers on the table, and that's fine. I'm gonna put that back in there. All right. Once you have this, right, you might want to screenshot it and save your work. Or if you want, you could redraw it on your own paper again. I leave that choice up to you. Let's see here. Not bad. Anyone finish? Brian, did you just decide to ignore my y values and just go by ones? Looks like you did. All right, all right. David, did you decide to change the colors along the way? I like that. Got a little gradient going. Brian's like, screw your metric. I can make it fit. All right, all right. Not bad, not bad. I'm gonna start a couple of these answers, and let's take a look at your responses, okay? And if you didn't finish it, you guys can just screenshot what I have posted on the screen from other students here. Do you guys know how to screenshot on your computer? Right? If you are dealing with let's do a little bit of a refresher here for you guys. If you're on a Chromebook, right? If you're on a Chromebook, screenshot for a Chromebook is 3 buttons, right? The 3 buttons are going to be Control, Shift, and then there's a button on the top of your keyboard that has a box with 3 little lines there. It's I think that's your tabs button. But if you hit Control, Shift, and press that button, your screen will go dark, and then you can drag and highlight your screen to copy and paste whatever you select. So if you like your graph and you don't want to redraw it again and you want to save it to your own notes online, you can just screenshot your Pear Deck right now and just make a copy and save that onto your drive, right? And print it out later or whatever you need to do with it. If you're on a Windows computer, right? If you're on a Windows computer, it's just 1 button off. Instead of pressing Control, Shift, and that, actually it's 2 buttons off, you're going to be pressing the Windows key, Shift, and then S. The Windows key, Shift, and S will allow you to screenshot on a Windows computer, right? On a Windows computer. Let me show you that. Where's the keyboard? They have a print screen button, but I'd rather you not do that. That just prints the whole screen. If you just want to do a selection of it, you press the Windows key, Shift, and then S. And when you press the Windows key, Shift, and S, the screen will go dark and allow you to select where you want to capture, right? Where you want to capture. And if you have a Mac, it's going to be the Command button, Shift, and then I believe 4. It's either 3 or 4. I can never remember correctly. One of them screenshots the whole screen, and one of them allows you to select which ones you want. Okay, so screenshotting that, the reason why I'm showing that is because I want to share a couple of students' responses here. And if you don't, if you don't have it done yet, that's okay. You could just screenshot what I have here. So here's one example, right? Very nicely drawn, just the dots here. Very, very good. Another person, right, did the dots here along the way. I'll give you a second if you want to screenshot that one. Or if you just want to screenshot your own, that's fine as well. It's 4 to select. Thank you, Julia. Thank you. So if you have a Windows, it's Control, Shift, and 4. Control, Shift, and 4. And here's one more with someone, whoever did this one, nicely done on labeling the axes, right? Distance on the y-axis and time on the x-axis. I like that. I like that. Okay. So hopefully you guys are able to plot those dots. Yeah. Yeah. So what I'm going to do right now is turn on student paste, so that way you guys can, if you're still working on these right here, you can stay on the screen to finish it up. But if you're already done with it, I'm going to ask you guys to move on to the next slide, right? And the next slide is this one right here, slide number 2, and it's going to look like this. Oh no, does it not all fit? Oh, it cut off the bottom of it. Ooh, that's not good. Yeah, that cut off the bottom of it there. Well, that's okay. You guys are going to just... you're not going to fill out this whole chart anyways. Okay, we're just going to do this one together here. So hopefully you guys got these points down. Okay, and hopefully you guys were able to graph it. And I'm moving on to slide 2. So if you guys could move on to slide 2, which is right here. So what we're going to do now after you have all those values, right, is we're going to be calculating the velocity, right? So what we have recorded there is the total distance, right? And we have the chart there of the total distance of someone's car ride, right? How far they traveled in total over 20 minutes, right? So what we're going to do now is let this guy right here, this little triangle with the S right there, we're going to let that represent the change in distance travel, right? So that little sign right there is a Greek letter called delta. Oh no, am I lagging? Not for me? Uh-oh. Let me know if I am lagging, guys. Yeah, it's okay. Okay. Yeah, try, if you need to rejoin, let me know. Just rejoin and see if that fixes it, or restart if you need to. I am recording this, so if you ever miss anything, you guys can watch the video. So, right, this is the symbol for delta, and we usually use delta to represent change, right? That's just the shorthand of it. So when we do something like delta S, that's going to represent the change in the distance traveled, and we're going to let delta T represent the change in time, right? The change in time. So we're going to calculate the velocity or the speed of the car for the given interval, And we're going to do the calculations by rows instead of by columns. So we're not going to just do all of these in this column and then all of these. We're going to just go one row at a time. Okay? So right here, and you don't have to fill it out on the Pear Deck all the way down, right? You don't have to fill it out on the Pear Deck. I just gave you that just so in case like you're too lazy to copy down this whole table. Okay? But if you just want to copy down the whole table, you can. So you don't have to put it on the Pear Deck, right? So check this out. Delta S is the change in the distance for the entire 20 minutes, right? So in the entire 20 minutes, how much change was there in the distance that was being traveled? Well, how far did he travel at the end there? This person traveled, or she traveled 11.3 miles. And how far did they travel at the very start of this How far did they travel at the very start of this? 0. That's right. Right, that's 0. So I need to calculate that. And then the change in time. How many minutes was it at the very end? It was 20 minutes. I'm sorry, yeah, 20 minutes minus, at the very start of it, 0 minutes. Right? At the very start of it, 0 minutes. Okay? All right. Give me 1 second. Give me 1 second. All right. So, using my calculator, right, I'm just going to go ahead and plug that in. 11.3 minus 0 is going to be 11.3. 20 minus 0 is going to be 20. So how fast was this person going? Well, the first part is if I divide those, right, if I divide that, understand that this is 11.3 miles divided by 20 minutes. So when I calculate this, I get 0.565, but I hope you realize that that 0.565 is in miles per minute, right? It's 0.565 miles per minute, right? And that's a weird unit, right? We don't really deal with miles per minute. Traditionally, when you're driving in your car, you're dealing with what? Miles per hour, right? Miles per hour. So how do I convert this thing? This is 0.565 miles per minute. Do you guys know how to convert that into miles per hour? What would I do to convert miles per minute into miles per hour? Any ideas? Multiply by 60. Very good. Or divide by 60. Which one is it? A lot more people going with multiply by 60. And that's pretty much the idea here. If I have 0.565 and this is miles per minute, right, to convert this, I just need to multiply, right, by 60 minutes for every hour, right? That way the minutes would cancel each other out. I'm left with miles per hour, right? We're left with miles per hour. So I just need to take this number, multiply it by 60. And I end up with 33.9 miles per hour. Is this person going fast or slow on average? What do you think? The entire trip for 20 minutes, he had an average velocity of 33 miles, let's round it 34 miles per hour. That's not too bad, right? All right. Looking at that data though, right, I don't know how fast he might have been going in between there. So we can actually do that and calculate that as well, right? So tell me, what do you think the first 10 minutes of this trip was? What values here? If I was looking for the first 10 minutes, when does the first minute start? I'm looking at the first 10 minutes. I'm hoping you realize here it's going to be from 0 to 10, right? That's the first 10 minutes. Okay, and then looking back at my table, I don't want to keep going back and forth here. Give me 1 second. I'm going to bring up my table over here. Oop. Okay. For the first 10 minutes, at the 10-minute mark, he's traveled a total of 6 miles, right? Minus at the very start, which is 0, so that's just going to be equal to 6 miles. The time that they traveled then is going to be 10 minutes at the very start minus 0, which is going to be 10 minutes. So with that being calculated there, plug this into the calculator. How fast was this person traveling? And go ahead and write that into your chart. How fast were they traveling? It's going to be 6 divided by 10. So 6 miles for every 10 minutes that they traveled right there. Gives them a rate of 0.6 miles per minute. Now again, if I want that in miles per hour, I just take that and I multiply that by 60. Right, so that gives me that this person's speed, the average speed that they were traveling for the first 10 minutes of their trip was 36 miles per hour. How you guys doing? You guys okay? This is like the part where we're connecting from the last section of the last chapter, right? Calculating the average something, right? So I'm looking at the average speed, if you guys are understanding what's going on here. I was looking at the average speed for this trip for the whole 20 minutes, right? That's the first row. Second row is telling me what the average speed was for the first 10 minutes, right? For the first 10 minutes. Okay, let's keep going. Let's keep going. Can you guys tell me what's the average speed for the last 10 minutes? And now the last 10 minutes, what do you think that is? You guys type into the chat. What are the last 10 minutes of this trip? Do you think it's from 10 to 20? Monica thinks it's 10 to 20. Anyone else? Anyone disagree or agree? Is it 10 to 20 for the last 10 minutes? 11 to 20. 11 to 20. And I think it's 11 to 20, right? The last 10 minutes is not including that 10. Right? Because if I go from 10 to 20, that's actually the last 11 minutes. And if you don't believe me, count it out. You actually have to include the number that you're counting there, right? So instead of it being 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? That would include that last one. It's actually going to be from 11 to 20, okay? So let's go ahead and calculate that. That's going to be, well, at the 20-minute mark, right, how far did this person travel? They traveled 11.3 miles. At the 11-minute mark, how far did they travel in total is going to be 6.7 miles. So that's going to be a total of 11.3 minus 6.7. What is that? It's going to give me 4.6. And the time that's changed is from 20 minus 11, and that's going to give me 9 minutes, right? 9 minutes. All right. What do I get? Calculating this out, 4.6 divided by 9. That gives me 0.51 repeating miles per minute. What is that in miles per hour? Well, just multiply that by 60, right? And I get there 30.6 repeating miles per hour. And that kind of makes sense, right? If the overall average was 33 miles per hour and the first 10 minutes was 36 miles per hour, that means that they had to drive a little bit slower on average for the last 10 minutes for it to average out to 33 miles, right? And that's all I'm looking at right here, right? Is if I go back and look at the scatter plot, I'm calculating the averages for different points on these scatter plots, right? So the rate of change, by the way, is just I'm just calculating, if you think about it, just my slope of these lines, right, as I'm going along here. Okay, so I'm doing it from 0 to 10, and I'm doing it from 11 to 20. We're just going to keep going here, and I want you guys to fill out these charts for me. You don't have to write all these numbers in the middle for me on the pair deck. All I really want is the last box. Can you guys get me the last box for along here? And if you're struggling with this, let me help you along with that. So the first one up is going to be the 5th minute through the 15th minute. And this one's a little tricky. When does the 5th minute start? When does the 5th minute start? The first minute is not actually 1, right? Do you know the first minute for this thing starts at 0? So when does the 5th minute start for this one? What do you guys think? This is actually a little difficult. What do you think? Where does it's actually starting at 4. That's right. It's actually starting at 4. It's crazy, right? But here's the hard part now. It goes all the way through the 15th minute. It goes all the way through the 15th minute. So the 5th minute starts at 4, and it goes through the 15th minute. And yeah, that's right, Calvin. I know I want to go from 4 to 14, but it's going to go through to the 15th minute, so it's actually going from 4 to 15. So can you guys calculate the miles per hour for that one? Yeah, it's weird. And then following that trend, what is the time for the 6th minute through the 10th minute? What would that be? What's the 6th minute in this one to the 10th minute? And that's going to be the minute 5 through 10. Yeah. So go through that. calculate the miles per hour for me. For that should take you about, I'd say about 5 minutes, maybe 6 minutes to finish all these. So let's go ahead and calculate these out here and see what it is for the 9th minute through the 10th minute. 8 through 10. And then I want to see if you guys can figure out then what would the time be for these key phrases right here for during. So I'll let you get through that. In 3 minutes, I'll check in on you on what you got for these guys. And then after the 3 minute mark, I'm going to check in after that, see what you guys got for these guys. Okay? So go ahead and do that right now. I'll set a timer for 3 minutes. I want you guys to try that out. I don't know where my mouse is. There you are. Let's go with 3 minute timer. By the way, we write down this chart if you want to. If you don't want to, you can just screenshot it once we finish it. Once we finish filling it out, you can screenshot it or just copy the notes that I have posted onto Canvas, right? This is more of just an activity. It's not like straight up like you're going to be using these for your notes. It's just a nice activity to see why we need to do what we need to do on the next section. But yeah, it's a little thing that connects it from last section. If you remember 1.4, can we see the table with the points? Of course. Sorry, that way you don't have to go back and forth. Yeah, there you go. Oh wait, but then will you be able to see the numbers that we need? Wait, yeah, of course you will be able to see it. It's on the pair deck. It's on the pair deck. You guys can see the table on the pair deck, right? Slide 2. Those everything that is down here, right, should be on slide 2 of your pair deck. So have that right there. And there's your table. Brandon's saying no, it's not. It's not. No, slide 2 should have it. Or am I tripping? It doesn't save. It doesn't save. Uh-oh. Our pair deck is still on slide 1. Oh, guys, I set I set pair deck to student pace, so you guys should be able to switch to slide 2 on your own. I left it that way because not everybody was done with it. You can change the slide manually now. So click on the little arrow. If you want, let me here. I'm gonna just force you guys onto slide 2. Right? Is everybody done with slide 1? Because I'm just gonna force you guys to slide 2 right now. Okay. Did that work? Are you guys all on slide 2 now? Whoops. No! I'm so sorry. I switched you guys back and forth, but hopefully you guys are there. There you go. Whew. Sorry. My fault, guys. Ooh. All right, let me reset that timer then. It's been more than 3. It's been almost 3 minutes, but let me reset that. Let's get you guys again. You can move on. Yeah. So there we go. So that's that. You should have that on there, and let me put this up here so you guys can see that. How much do we round to? Just 1 decimal place. Let's round to 1 decimal place. Keep it simple. Okay. Some of you guys are filling it all out completely. That's awesome. Some of you guys are writing it by hand. That's impressive. Some of you guys are typing it out. That works too. Just fill it out. And I'm a little saddened that you can't see the last one, that at precisely 10 minutes. All right, I'm going to steal a couple of your answers here. So hopefully you have the table somewhere, because I'm going to scroll down here and I'm going to steal some of your answers and write these down. A couple people for the 5th minute through the 15th minute got this answer. You guys got 35.4. 35.4 miles per hour. Right? I think that's what you guys got. Right? Because for this one right here, for the 5th minute through the 15th, it should have been, the distance was, 15th minute was 9, and the 4th minute was 2.5. So you should have got 9 minus 2.5. And then for this one, you should have got 15 minus 4. This should have been 11. And then that one should have been, what is that, 6.5? Right? So this one should have been 6.5 divided by 11, which, just plug that into the calculator. 6.5 divided by 11, 0.5909 or whatever it is. And then you multiply that by 60. That's how people are getting the 35.454. I would round that to 35.5 if you wanted to round it to there, but you could also just put 0.45 repeating. But if you're rounding that, right, make sure you round correctly. Right? That should be rounded up to 35.5 if you're rounding that. Okay. All right. Stealing some people's answers here. It looks like the next one they got over here is 30 miles per hour. 30 miles per hour. Oh, you got 33.6? My fault. Oh, the 6th minute through the 10th minute is 33.6. You're right. I was copying off your screen too, Calvin. I just looked at the wrong box. 33.6 miles per hour. And then I saw someone else. 30 was for the next one. Cheater. Yeah, I am. A little bit of a cheater. Now, here's the tricky part. Did you guys figure out how to calculate the velocity for the 5th minute? What's the interval for the 5th minute? When does the 5th minute start and when does the 5th minute end? Calvin, you do one. All right, I'll do this one. The 5th minute, guys, I'm hoping you see that the 5th minute starts at 4. The 5th minute starts at 4, right? It starts at 4. And when does it finish? It finishes at 5. So during the 5th minute, it's actually that interval from 4 to 5, right? That interval right there from 4 to 5. Now, Calvin's challenging me and telling me I do one. All right, I'll do this one right here. And let me get that value for you. It's going to be the distance at 5, which is going to be 3.2, minus the distance at 4, which is 2.5. And that's going to give me, let's see here, 3.2 minus 2.5. That's going to give me 0.7 miles that they traveled in that interval. And then that's going to be 5 minus 4, which is equal to 1 minute, right? 1 minute. So that's going to give me 0.7 miles per minute. Or in other words, how fast is this person going? This person was going 42 miles per hour at this minute. So That's the average travel, by the way. That's not at exactly, the 5th minute, right? It's the time between during the 5th minute, right? It's over this interval of 1 minute. They had an average speed of 42 miles per hour. Whereas earlier, right, we had an interval from the 9th minute to the 10th minute, and we found out that average speed was 30 miles per hour, right? So I don't know if you guys noticed this, but the intervals are getting smaller and smaller, right? We're getting smaller and smaller on these intervals, and we're able to calculate the average speed for smaller and smaller intervals for the interval from the 6th minute to the 10th minute or the 9th minute to the 10th minute. Now we're going to just do it during the 10th minute. And during the 10th minute, that is 9 to 10, right? 9 to 10. And that's going to give me here, this is going to be 6 at 10 minutes minus 5.3, which is 0.7. And this one right here is going to give me 10 minus 9, which is going to give me 1, which looks like it's about another 0.7 miles per minute again. So the average time during the 10th minute is also 42 miles per hour, right? And then we could do the same thing for the 16th minute, right? The 16th minute is going to be 15 to 16, and that's going to give me, let's see how fast he was traveling here from the 15 minutes to the 16th minute, right? For during the 16th minute. Let's see here, that's going to be 5.3 minus 5.0, which is going to be 0.3. And then this, of course, is equal to 1 minute again. And this is going to be 0.3 miles per minute. Whoops, I did not mean to click on that. Oh, get out of the way. I don't know where my mouse is. Hold up a second. There you are. That's going to be, come on over here. There we go. Why are you like this? There we go. That's set up a little bit better. So that's going to be 0.3 divided by, multiplied by 60 to tell me how fast that is in miles per hour. And the average speed for that minute, for that 16th minute, this person was going 18 miles per hour. They were traveling like a snail, right? Does that mean that for the whole entire minute, they were going 18 miles per hour? What do you think? Is that what that means? For the 16th minute? Perhaps. I like that answer. Yeah, perhaps. That could be the case. They could have been going really slow for that 16th minute, right? Or what else could have happened during that 16th minute in between 15 and 16? What else could have happened? Does anyone know? They were probably at a stoplight. They were stopping. Yeah, that's a possibility as well, right? They could have gone 25 miles per hour, and then for 30 seconds they were stopped, right? Or they were already stopped for some time in between there, and then they took off. We don't know though, do we? We have an idea though, right? We have an idea based off of these averages. They could have been doing donuts. I mean, true, right? True. Now, here's the last part I wanted to talk to you about then. If we calculate during these intervals from minute 9 to minute 10, right? Or minute 4 to minute 5, or minute 15 to minute 16, what do you think the average speed was precisely at 10 minutes? How would I calculate that? If it's precisely at 10 minutes, right? If it's precisely at 10 minutes, this person had traveled a total of 6 miles minus 6 miles, which means they traveled no miles. And then if I look at the time, I'm looking at 10 minutes minus 10 minutes, which is equal to 0. And if I do that division, I end up with 0 over 0. I end up with 0 miles over 0 minutes, which means if we were talking about that mathematically, it's something that's undefined, right? But we know that if we were doing this and we were in the car at precisely 10 minutes, the car was going at a specific speed, was it not? It was you were actually moving, right? Or even if you weren't moving, 0 would be a value as well. And at precisely 10 minutes, we can't calculate this average, can we? We get something that's undefined because you're looking at this dot at this time, they traveled this far, and this dot at this time, they traveled this far. We can calculate that slope, right? That makes sense. That's the average speed, by the way, is the slope between those 2 points, right? But if I'm asking for you at precisely 10 minutes, what's happened there? You're getting that point, and you're getting closer and closer to 10 minutes. So let's say I was looking at 10 minutes, and then I was looking at 11 minutes, right? And I was trying to calculate the average speed from 10 minutes to 11 minutes. I can calculate that slope very easily, right? That's that line right there that I'm drawing with my fingers, right? And if you're having trouble seeing what I'm doing here, what I'm saying is, let's say at 10 minutes they traveled this far, right, on this chart, and at 11 minutes they traveled this far. If I was asking for the average speed, right? You just draw the line here and you just calculate that slope, right? And then if let's say I didn't do it at 11 minutes, let's say I had asked you guys to record every 30 seconds and you found out, oh, at 10 and a half minutes, it was like right here, okay? So from 10 to 11, you get this slope, but from 10 to 10 and a half, you get this slope. See that? So the closer I get to that, the more accurate my calculation is going to be for the speed at 10. Does that make sense? So at 10 to 11, the average speed there is a nice estimate, but it's not a super accurate one. But if I do it to 10 and a half, which I don't have that data for, but if I did, it'd be a little bit closer. You understand that slope is a little bit closer to that now. Now, if I go even further and go to like 10.1, right? I can calculate that average now, right? Because if I was doing that that speed, it would be, so just a heads up, this is what's going on here. What I'm asking from you guys to understand is, if I was calculating the average speed from like 10 to 11, it would just be 11 minus 10, and then you just calculate your answer. If I got a little bit closer on my point and I got to 10 and a half minus 10, I can still calculate that average, and that average is going to be very, very close to 10, right? And I could go even closer. I can go to 10.1 minus 10 and calculate that average. The only problem is at 10 itself, I do 10 minus 10, I end up with a 0 in the denominator. That means that, that function is not defined there. But from what we learned from chapter 1, you guys understand, right? The limit of that approaches a number, right? And the limit of that approaches some number, some value, which would tell me what was that velocity exactly at 10, right? Exactly at 10. And that's what's leading up to our new lesson today. Okay, so I went through all this stuff and like, why did you go through all this? And it's just, I want you to get that idea, right? If you record distances over a specific amount of times, you can calculate the average, but you won't be able to calculate the instantaneous velocity at a specific point, right? But we can get pretty darn close, right? How close can we get? We can get arbitrarily close. What does that mean? We learned a whole chapter on limits, right? The limit as x approaches a value. How close does that get when you're dealing with that limit? It gets arbitrarily close. And that was the main concept of what calculus is you're trying to calculate the speed of something at a specific time. We won't be able to using our old slope formula. We'll get something that's undefined. But if we looked at limits, right, as we approach it closer and closer to it, that's our technique that we're going to be using to calculate the speed at a specific spot. And if this is all going over your head, don't worry, right? It went over my head the first time I went over this as well. So let's go over to here. I'm going to move over here on the slide to 2.1. Right, give me 1 second here. Am I going to ask you guys to sketch this graph on your own? No, of course not. I drew this graph for you, and I'm going to give you the slide right now. So I'm going to move the slide over. Don't worry if you don't have it copied down. It's not too important. Plus, it's all posted online. You can go and get those values later, okay? So I'm going to go ahead and move the slide on to the next one. I have this graph for you, but I don't have the function written down, so you might want to write this down in your notes, okay? So let's say I was looking at a function y is equal to x squared, right? Y is equal to x squared. You guys see the parabola drawn here, right? I changed the scale so it's a little bit easier to see what's happening when x is equal to 10. So the x values are going by 2s. You see that? 2, 4, right? 2, 4, 6, 8, 10. But the y values are going by 20s. And that's just I just messed with the scale so we can see it a little bit better. Okay? So what I was saying, right, is this whole idea of trying to calculate, if we were trying to calculate the average speed. But when you think about it as a graph of like time and distance, the speed is just the slope of a line between one point position to another point / position, right? So I call that the slope of a secant line. It's connecting the two dots right there, and we'd have a secant line drawn there. Okay, so give me a second here. So with that being said, looking at this function, right, y is equal to x squared, think of this as some random function, and the bottom values is just some t time again, going from like 0 all the way up to 10. and then the y value is just some distance, right? So if I was looking at this, I want to anchor a point real quick. I'm going to anchor a point. You guys understand what it means to anchor a point, right? We're going to use a point, and we're just going to be focused as our anchor point as our focus point. So I'm going to look at 2, 4 as my anchor, right? 2, 4 as my anchor. And that's right here. You see that? This dot right down here? That's my anchor point, okay? And that's kind of like saying, like, could I figure out what the slope is at exactly 2? Could I calculate what is the speed of whatever this is at exactly 2, right? Could I calculate that slope? Before I do that, though, I'm going to go a little bit further out. So if my anchor point is at 2, 4, I'm going to see what's my slope at x equals 10 to this anchor point down here, right? So at x equals 10, right, looking at this function, that's this point up here. Can somebody tell me what's the point? What's the ordered pair for x equals 10 using this function? Right, it's going to be 10, what? What do you guys think that point is? What do you think that point is? 10, 100. Very good. How'd you get that? That is right. That is right. I looked. Yeah, that's a good. Yeah, that's fair. You looked. There's another way you could also do it, right? And that's just plugging it into the function, right? But you're right. You could just look and just see, like, bam, it's at 100. But if I plugged in 10 in for x, it'll be 100. It'll be 10 squared, which is 100. And that's how we got that, right? Now check this out. I'm asking you guys to calculate the slope from this anchor point, to x equals 10, right? I want the slope of that line. So I'm going to go ahead and draw this line. And you don't have to draw this either, but I'm going to draw it right here. Come on, buddy. Just work with me here. Do I need to draw this freehand because this thing doesn't want to go to the right degree? I got you. I got you. Boom. And like so. Bam. That's beautiful, right? So what I'm asking right now is calculating the slope of this secant line from x equals 10 to my anchor point, right? This is going to be my anchor point. This is where I'm focusing on, right here. So to calculate that slope, all I got to do is use the slope formula, right? Just like we were doing earlier with all those speeds and all those distances, right? We can calculate, all those distances all those times. So I can calculate this one as well. This is going to be change in the y values, which in this case is going to be 100 minus 4, right? Are you guys okay with why it's 4? Right? Because my anchor point is down here at 2, 4. Okay? So it's going to be 100 minus 4 divided by 10 minus 2. 10 minus 2. So I calculate this out. I end up with 96 over 8, which simplifies out to 12. And what does that necessarily mean? The slope of this line, the slope of this secant line is equal to 12, right? That means it's changing with a height of 12 for every x value of 1, right? So it goes up 12 over 1, up 12 over 1. And that's that slope there. And that's the average speed if you think about it, if this was position, right? If this was a graph of position versus time, then the average speed from the anchor point of 2 all the way to the anchor point of 10 is 12 miles per hour if this was miles in, time and all that stuff. If x was in hours, I should say, not in minutes. Okay? And that's it, right? So what we were doing earlier, though, we were focusing on exactly like one anchor point. And this time, this anchor point is 2. So I'm going to get my next point here to get closer to my x equals 2. Instead of x equaling 10, I'm going to go to x equals 6 now. Where's x equals 6? Let's do that. Let's do that right here. X equals 6 is this dot right here, right? There's this dot right here. So it's 6, all right, Calvin. Are your eyes good enough to see where's that dot located at? 6 and what? 6, what? Max is in there. Max typed it in. Good. 6, 36. 6, 36. Right? Again, you can just plug it into the function, right? If you have a hard time seeing where that dot is on the graph. But now here's what I'm trying to do. What's the secant? What's the slope of this secant line? What's the slope of this secant line right here, going from here to there. What's that one? We'll just plug it in. Let's just calculate it. This is going to be 36 minus 4 divided by, right, 6 minus 2. That's going to equal to 32 over 4, which is going to equal out to 8. All right, so that has a slope of 8. You guys see that? Slope of 8. All right, here's what I want you guys to do. Can you calculate the slope for the next 3 points I have labeled there? X equals 4 is going to be the next one. X equals 4 is right here, right? And then that's going to be 4 comma 16 if you have trouble finding these points. I'll give you that one. And then calculate it for x equals -1, which is back here. And the last one, calculate it for x equals 3. X equals 3. Can you guys go ahead and calculate those slopes for me real quick? The slopes of those ones for me. So tell me, what is the slope going to equal to if I did the work right here when x is equal to 4? What's the slope going to equal to when x equals -1? And what's the slope going to equal to when x equals to 3? Ooh. It's on the. Did I put the pear deck on the right slide for you guys? Does it have that graph there? You can also answer it on there as well. Yeah, it's there. Oh, it even has the values for you. How nice of me to put down those values for you. So go ahead and start answering that. You don't have to show the work on the pear deck. You can do the work on your own paper. Just show me the answers on the pear deck, and I'm going to be a thief and steal your answers and put them onto my notes. All right, so we're doing 3 of these. 3 minutes should be more than enough time. Brian, double check your x equals to -1 answer. Brian V, check that. Double check that answer for x equals -1. Same thing for you, Monica. Double check your answer for x equals -1. Max, double check your answer for x equals to -1. Angela, double check your answer for x equals 4. Okay. Good. Good job, Oscar. Good job. Good job, Jeffrey. Good job, Max. Way to fix it. Kimberly, good job. Brian, you might need to double check your answer for x equals -1. Good job, Kaylee. Fatima, good job so far. Get that last one in there. David, good job. Good. Leslie, good job. said Brandon had an answer, but it's gone now. Did you delete that? Oh, God, my ears. All right. Sorry, I got to figure out a better timer that has like a better alarm. All right, let's go over these. Okay, so the answers that you should have got, right, that I've seen from most people here, is that when x is equal to 4, they got a slope of 6. When x is equal to -1, they got a slope of 1. And if x is equal to 3, they got a slope of 5. And if you got different answers, you just need to double check your pluses and minuses as you go through that, right? So if when x is equal to 4, the slope you should have got, right, the slope you should have got should have been 16 minus 4. And in the bottom over here is going to be 4 minus 2, I believe, if that is the right anchor point that I'm looking at here. So, right? And then for x equals -1, if I plug that in, the point should be -1, 1. So the slope for this guy, right, should be 1 minus 4 over -1 minus 2, right? I hope I did that right. And this in the top should be a -3, and in the bottom should be -1 minus 2, which is going to be -3, right? Did I mess up? Uh-oh, I messed up some more? Oh, no, that's something else. That was from like 7 minutes ago. All right, so yeah, so that's why that's a 1, and the last one's a 5, and you can double check that out. But what we've essentially done here, right, was we picked an anchor point, and we calculated slopes along the way there, right? As we got closer and closer to the anchor point. I'll put that back up in a second there, but I just wanted to show you this. So what we've essentially done was calculate a slope from 2 to 10 minutes, or from x equals 2 to 10, and then we did it from 2 to 6, and then we did it from 2 to 4, and then we did it from 2 to 3, and 2 to 3 looks like this. Oh God, hold up. I'm sorry. I can do this. Boom. See that? Boom. And then we did it one more time from -1 to 2. Boom, back there. Right, so we calculated these slopes for these secant lines, right? We calculated these slopes for these secant lines all the way through, right? We calculated all the way through. So I'm kind of moving it along as it gets closer and closer. I get this new value, right, as I approach this anchor point of x equals to 2. Okay? Now, what does this all mean? Well, if you think about it with what we've been learning, right, with limits, right, I'm just getting this point closer and closer to each other. And as the points get closer and closer to each other, it's starting to give me a slope of a line that's pretty much almost on that point and only that point, right? So what does that say? Well, let's take a look at it. Okay? I'm going to go on to the next one. Let's pick a different anchor point this time, right? Same graph, different anchor point, right? But we're going to calculate the slope for these guys. All right, I'm going to move your slide over. I'm going to move your slide over. We're going to do the next slide right here. On this next slide, my new anchor point now is going to be 3, 9. And 3, 9 is right here. This is going to be my new anchor point. My new anchor point is at 3, 9. Right? Just like we did earlier, we're calculating now the slope. Instead of from x equals 2, we're going to do it at x equals 3. And we're going to calculate the slopes as it approaches this new anchor point. Okay? How much time do I have left? God, I only have 7 minutes left. What the heck happened today? Okay, so let's start off. My new one right here is going to be at x equals 10. Right? That's going to be this one right here. That slope right there. So at x equals 10, what's the point? What's the value there? It's 10 comma what? 10 comma 100. Right? We're going to calculate this slope now. So it's going to be 100 minus 9 over 10 minus 3. Right? 10 minus 3. And that's going to give me a slope of that secant line I just drew is going to be 91 over 7, which is equal to 13. Right? It's equal to 13. Can you calculate these new secant lines for me? I don't have it written down on the pear deck for you this time. Right? I don't have it written down for the pear deck for you this time. Instead, it's just written on my screen. So if you guys could calculate these next 3 secant lines for me. I want you to do it for x equals 8, x equals 2, and x equals -1. that dot is not at x equals 8, by the way. That dot is at x equals 6. So be careful with that one when you're drawing that. This is a 6. At x equals 8, by the way, that dot is going to be over here at x equals 8. Right? So that's going to be x equals 8, comma, whatever that point is. Calculate that slope for me. Write that down. You don't have to show the work again. Again, I just want the values. I just want the values. So tell me what is it equal to for that slope. And then the next one is at x equals 2. And at x equals 2 is right here. I'm not going to draw it up on there. I'm going to draw it down here. X equals 2, comma, whatever that value is. Give me that slope right here. And then the last one is going to be at x equals to negative 1, which is back here. Give me that slope as well. Right, so I'm going to draw these out. You don't have to draw these out as well. I'm just drawing them out just because it helps me to see the secant line of the slope that we're approaching. So that's that one. And then at x equals 2 is going to be this one right here. And then the last one is going to be at x equals negative 1, which is right, oh God, right there. Boom. So I'm just drawing the slope of these, I'm just drawing these secant lines out. I'm calculating the slope of all of these secant lines that are approaching here. Okay. So get that in there. So it took a little bit longer than I thought it would. Beautiful answers I got already from some of you guys. Yeah, good job typing that out for me. So you guys are still working on it? That's okay. By the way, guys, when you're doing these stuff and you're calculating slope, you don't have to do it by hand. If you want to just use your calculator, you can. All right. All right. Let's share some of the answers you guys got, because I only got 3 minutes left and we're going to call it here. And I promise you this will all connect at some point later on. But let's take a look at what answers you guys got here. So when we're anchoring at 3,9 this time, it looks like when x is equal to 8, you guys should have got a slope for that secant line that's in red there. You should have got a slope, or I'm sorry, that's in purple. You should have got a slope of 11. Okay, that's the slope right there for that purple line. And then we did it again for x equals 2, and that's this green line right here. And it doesn't look as steep, right? It doesn't look as steep, and it's not. The slope, if you were to calculate it at x equals 2, you should have got 5. You got 5. And then the last one at x equals to negative 1, that looks definitely not as steep at all, right? So we got a slope there of 2. We got a slope there of 2. Okay? And yeah, I know that we're like, what the heck is all this stuff? Why are we calculating so many slopes? And why are we moving these dots around a fixed point? And that's where we're gonna, that's where we're gonna leave off right now. We're gonna build up into our next lesson of what the heck is happening. Well, I thought we were just looking at a slope at a specific point, but we're building our way there, right? We're calculating all these points and we're just moving it along the way. And hopefully you'll see that it leads to what the next big concept is in Calc, right? And you're gonna see like, oh, okay, I've heard that word before. I'm pretty sure a lot of you have. And we're going to learn about what that word means once we've connected all these dots. figuratively connected all these dots. Anyways, guys, that's it for me today. I'm going to end it here. We're going to continue this stuff on the other slides next time. And yeah, hopefully we'll have your tests graded by Monday with your scores. All right. And that's it from me, guys. I'll see you guys next week. And until then, stay out of trouble, stay out of jail, and don't get pregnant. All right. Have a good weekend, guys. So long.